Okay, welcome back to yet another live stream where we're slowly writing a small interpreter in C++. Excuse me. It is Saturday night and about 9:27 according to my computer clock. Not too much else to report. We left off. We were still just doing the type checker. The code is still terrible, but we shall gradually tidy that. We've got a huge number of to-dos which we are promptly ignoring. It's pretty cold in here as well for some reason. I just want to spend an hour, finish off the type checker if we can. Maybe print it out, put it into the pretty printer for the AST so we can see what types it thinks we've got. Remembering that we dropped the 64 for now, and then finally we can tidy the code away, and well, I don't imagine we're going much further than that, so without further ado, let's try and remember what I was doing. I've forgotten. Obviously about to do a function call. So the first thing about a function call is when this is inside the rather large check types function. A function call now that's a poorly named thing. Because that's returning a type, isn't it? So we have to return. Oh God. I just constantly think about this. Where did it go? That we're going to be making so many copies of this vector. And it's going to run slow. Well, I suppose it's going to be empty most of the time, so it's not going to be too bad. But next thing, we need to count the number of args. Let's do this in line. Still not renamed sibling. Obviously, if we keep doing this a lot, we'll make a little function up called count params, and when parameters are formal parameters, really, that are specify the inputs to a function. Arguments are the values given to those inputs. Okay, so we know the number of parameters. We now have to that is wrong. It would be that, isn't it? This is numargs. Ooh, come on you. see if we can do this. I've decided to start doing that. The line, what would you call it? Advertising leaflet that contains a whole selection of, I don't even know how to see that. Flip to there. No, you're not going to make it out. Whole load of completion of, keyboard shortcuts. I've got completion on my head. I'm just trying to look up bookmarks. Probably could Google this quicker. It's gone silent. Bookmarks. Toggle bookmark F11. So to go to 11, and I just want to add a little. Now, how do I get Shift F11, of course? How do I make a numbered bookmark? Nope. Maybe I've done Control F11. I do Control F11. Trying to remember that, but I've got a feeling I won't. Right, so if numbers parameters is not the same, then all is terrible. Right. What's the best way to do this? Size T X 0. When you've got thin things, in fact, it can be a for loop. So what we're going to do is we're going to now iterate over the arguments. Evaluate to get, not evaluate, run the check types on them, on each individual one, and check that the type returned is the same as the expected type. Now there's one more thing to do here. To can't remember if we do that. Do we do okay, the classic for loop. Don't currently support parsing. Function pointers. God, I'm suffering today. Don't currently support function pointers, therefore we can just look at the kind. So still calling it kind even after renaming it return type a little while back. Nope. See, we can code stuff. No, he doesn't like that. Normally it tells me, I think it should be a... so many to choose from. VI, is that right? Yes. Type mismatch in return. That doesn't sound good. Oh, perfect, look at that. Said that we're returning a ball, we're not. Yay, my type checker's working. Maybe. No, it's not. Right, let's take you out for starters because we're not doing I64s. Okay. Interesting, because foo returns a void. Oh, we've got to put that logic in, and wait if it's a void return. Don't worry about it. Make sure What's a function call got to do with that? Here we go. Start this on this code up. Shift F9 for the debugger. It took me a minute. Right, what have we got? Command function. Okay, not that wide about you. Turn. Ball. Your return type from the evaluation, which is type. Is a I32. And does that sound right? Oh, of course it is, because it's return there. Good. Turn true. Function def. And let's start as we see them, put those two failures. Probably I'll return an exit code of some type to describe it, so IDEs can, scripts can see what's going on. Maybe not, because I might have stood out. Okay, not the correct type. Shift F9. Let's go to you, and you. Okay, what have we got going on? Let's look at the node. What is it returning? It's returning a ball. Good. Whose type is void? That's because where are we? Cool. Right. So we decided a little while back to make, if it's a void, return success. This should always return void because it doesn't actually do anything with the return consumes the type. So if we look up here, we should be somewhere where we're using the current function to check the return type. There you go. So we don't actually need that. Comment it out for now. you go. Awesome. What we've got going on there? Yep. Take you out. It should still be void. Yes, we've not got this bliss return there. Type expansion return. Yep. So that completes our type checker. Air quotes, because we have not tested it and there's going to be loads of bugs. But complete. And you know what we do when we got that? I'm thinking that I will it really annoys me. Thinking what I'm going to do is so we were talking at the beginning. I was saying I'll probably add it to the AST printing, but it's going to make the AST printing quite noisy, much harder to read. So I'm trying to think. My goal is to get this bug free. Obviously, there's going to be, I would imagine, 10 to 15 bugs in there. I don't actually know, but there's quite a few, I imagine, and mistakes and things I haven't thought through properly. So we need to get a set of tests on it eventually to really sort of stress it out. But printing out the I don't want to go in, make the pretty printing of the ST look messy. Let's have a look at it. So I'd probably end up putting something. Well, parameter it knows that, but a unary one, and what you would put a type in there. You wouldn't need a plus. You could say which type it was. Plus plus. Int there. Third. Put a bracket and go. No. Excuse me. Put a bracket there and put the type in. No, let's not do that at the moment. I gotta think that's actually a good idea. But for now, do we need it? Let's not add it. Type analysis. So now the goal is to put everything we can, get everything out of main, so we can move on. And what to do's and ifs. This guy is not happy. Let's leave that in. See? Don't actually need much. Exposed. I think you can analyze symbols. Let's zoom in a little bit so you can see what's going on. Look, I think one of those cool. I know it won't double include, but awesome. In fact, that was a little bit too easy. Okay, I've got a thing about liking statics. A lot of people like to use anonymous namespaces. I am not a fan. Which I shall iterate my 2 reasons why in one moment. At one point static for this was deprecated in C++, I believe, and then they changed their minds. I could be wrong on that. Pretty sure I remember being deprecated. And it's not anymore. So anonymous namespaces let you do a very similar thing. They, say local to this file. Now, I've got one sort of conceptual problem with that. Is that the fact that you're saying it's local to the file is shifted a long way away from your function declaration. You really want to say private in the line you're declaring the function, because then you can take it off and it's a bit of information you'd like to see straight away. So shifting that off, saying private 50 lines above the file, means that you're going to waste time going up to see whether it's private or not. Or you've got to guess, or if you're in an IDE it might tell you. So you waste time, effectively. Occasionally waste time. There's the tiny bit of time you gain because you'd have to type private on them all. But probably when you're making a new function, you then have to make sure you're not in the anonymous namespace. So it's not complicated, but it just adds a little bit of horribleness to your workflow. The other thing is that the moment you stop using a static function, the compiler complains and says, hey, we've got warnings up, hey, you're not being used. Let's see if we static void foo compiler warnings up. We'll throw out the compiler warnings, but won't we get up to warning level 3 or something? That will be a warning saying this function's not being used. Now, I've never looked, well, I have looked, I looked on Visual Studio, and it doesn't complain about unused anonymous functions. Maybe if I put the warning level up to warning level 4 it would, but that's my practical reason. So 1 is it's a bad idea because you've always got to know whether you're in which namespace you're in, and it's not obvious. Whereas if you put the scoping at the beginning of the function, like most other languages do, you don't waste any time. Obviously, I prefer to type public and have everything else by default private, which is what some languages like Rust do. But that's a choice made a long time ago by C, so I guess 70s. When probably there were more if it was public. I don't know. It'd be interesting to go back in time and see their reasoning. Right. Oh dear. Excuse me. How are we doing for time? We've not been streaming very long, have we? What is it? Let me check the health of the stream. Half an hour. Next up, the big one. Some of you may have noticed that my directory is a small games directory. I write small little games occasionally, don't really publish much. More they normally end up being code experiments. I try and write something in Rust, or I try some new features of C++ or something, so often the games don't get finished. Well, one of my other resolutions this year was start to finish things. On top of streaming, defensive arm closing, arm folding. So it may be eventually I start doing some games programming. Probably not in this little language you're writing. I think it's going to take a fair while before we get this looking good. But either C, C++, or Rust if I feel like it. Although I'm promised to get all the dust off my keyboard, sorry. I promised myself I'm not going to look at Rust for another 6 months at least. Just nothing with the language. Compiles a bit slow, but more about the libraries. Just waiting for those to get a little bit more mature. Obviously, there's a lot of things that are mature there. Also, I don't know if you guys saw that I don't really follow this stuff. Just recently, there's been a few sort of pushback articles where people are saying, you know what, the win on Rust isn't as good as I was hoping, and there's one by a guy who wrote something in C, and he was saying that his iteration times were faster, and I probably lost the links. Didn't fully agree with everything he was saying. I think everyone brings their own bias, and if they're determined to dislike something, they find something to dislike in it. But I try not to be like that. I kind of like Rust. It didn't really fit with my when I was looking to write small bits of code and just learn little things, then it doesn't really fit with that, because I'm having to stand to the the formal. When I'm figuring something out, I don't mind if the memory leaks in a small 50-line program. I just want to get to the concept and see. I mean, I don't deliberately write memory leaks, but I'm not running Valgrind over it. For instance, we've not clicked Valgrind on this, shall we? And it's a moment as this. Nothing to show, so it's all good. We do not leak. any memory. We haven't got a very complicated memory model yet, so memory allocation schemes. And we're going to avoid having anything complicated. Where was I? I'm digressing because I'm just thinking about what to do next. So that sort of write 50 lines, figure out some algorithm or figure out something doesn't seem, for me anyway, to gel with Rust that well. I seem to feel it's a bit formal and it compiles a bit slow. And when I'm at home, I want to be I'm just coding, I don't want to be waiting for code. Compile times are getting better, and I suspect some of it is somebody else said it's my lack of familiarity. At the moment I was going to do a bigger project, I would certainly, or have considered it. For instance, I started writing this little interpreter in Rust to begin with, but I found I was going too slow and I didn't want to be learning Rust doing that. While writing an interpreter, I wanted to have fun writing an interpreter. So I kind of dropped Rust after a couple of episodes. It's not, try it, it's great, I suppose. If I was going to write a big game, certainly consider Rust, but I wouldn't consider it till the library's a bit more mature. So that's why I said to myself, no Rust for 6 months or 7 months. And every time I say that, I come back to it and I'm like, wow, it's improved. So hopefully, and it does seem to be picking up some users within the game industry now, which is good. I cannot remember how I got onto this. Not quite sure why I want those kicking around. Yes, we do. So we've annotated. Yeah, good point. Yeah, quite cool. You know what? I have this mixed view on this. So if we ever do some stuff, otherwise we turn the empty symbol tables, which is fine. We want to keep the symbol tables around for as long as they work. Writing code like this in Rust would be quite difficult because we're creating we'd have to use, well, I suppose we are using boxes and stuff. We'd have to use pointers, creating the AST to refer to things that are ahead of it. So you'd use boxes, which are pointers in Rust, except that a box pointer, so I think they call it boxed values, which are heap allocated, are unique pointers in in Rust, and we've gone with raw pointers, so we have no ownership. The ownership's handled inside this object, the AST object, and the symtabs object, which is minimising the places we do ownership, because eventually I want to get a lot of these data structures back to structures so we can use memory arenas. I suppose with Rust you'd use a weak pointer, which wouldn't imply ownership. Yeah, must be some nice solutions there. Be interesting to figure it out. Right, we can move a to-do. Now, what next? Right, code compiler. Wait, code interpreter. Could implement a thing that just interpreted the AST. Excuse me. which would be not a bad idea, but also not really a good idea. Why would it be a bad idea? We want us to stack overflows. But simple. Before starting this stream, I had my heart set on writing a bytecode interpreter. I should write one. I've not written one for over a decade. Or let me think about that for a while. And while I'm doing that, I think I might go and make a quick cup of tea. Which I've never done this before. I should really have a while I think cup of tea. Or hot water, I haven't really decided yet. While I think about that, then I'll come back to you and tell you why I'm jumping around on both of those. Right, see you in a minute. no... I don't know what type of tea I got. More importantly, I cannot find my tea cup mat thing. And sorry, excuse the brief longer delay. Kettles don't take that long to boil. I was talking dissertations on my other half. Okay. Right. Yeah, I meant to be thinking about what I was going to say. So our two choices are we make a code compiler and interpreter, plus point it will be faster. We're just thrashing out some ideas. Much simpler to probably get, well, I'm confident I can get this done in a few evenings, if not quicker. All we're doing is write one function called eval, and off we go. We have a stack, push things, pop things, job done. We need a scopes and stuff, but it's pretty simple to do. We could have a map or an array, and very well known. Put minus, it's slower, no, because we've already said that, so it's repeating of information. Minus possible flow. Well, I said I wouldn't do it. It'll probably take me a week or two to get that working rather than a few evenings. There's a lot more to it. You've got to do the bytecode. It's just more code to write. I imagine an AST interpreter will probably amount to 300 or 400 lines for what we need. The bytecode interpreter, I would imagine 800-900, maybe more. I'll have to remember to do a line count. The advantage of this is easier. We are part way to compiling to an XC, which is a bonus. I'm not sure I'm ever going to go that way, but as it's typed language, it's going to be a system language, so there's going to be no GC. There's no reason we couldn't compile to an XC. But we're only a part way there. The bytecode I'm imagining would be envisaging, would be a good word, use good words, and, is probably fairly high level, so it wouldn't be mapping to assembly instructions, and I am not the greatest assembly programmer. In fact, I'm not really one. Done a bit. So we would, it would still be a massive learning curve to go from a bytecode interpreter to producing an executable, or even just some assembly code that a assembler like NASM could compile. But it would move us in that direction. It'd force us to start doing resolving and stuff like that. We might even be able to take the bytecode, do a couple of transforms, send it out to the assembler. Here we go. But if we want to see, which is another route to get into an executable, route so we did the export to C, which we could then compile down using GCC or Clang, or the Visual Studio compiler. The compiler bytecode offers no advantage. not really decided yet, but C++ has constant expression, Zeek has comp time, and I believe Rust does some cool macro stuff. So they've all got compile time expressions. And, Twitch is letting me know someone's doing something. Cool. So it's likely that you might want to do some compile time evaluation. Now, if you're going to start doing that, you don't want to be doing it on an AST interpreter because it runs the risk that Stack Overflows. You know, it's just not a great way of doing it. So this would be a transient thing to get us going. Which isn't bad. Now the point of this is to have some fun. I've not done a bytecode compiler for a while. 15 years, 10 years, 15 years. No, that's not true. Not done a significant one. I did write a little calculator one that compiled to just in time compiled down to assembly code into a memory and then called the memory as a function and generated the calculated number. But that was probably 7-8 years back. As I was trying to work out how just-in-time code worked. It's quite simple, although it got more complicated now because you've got the security, memory security stuff going on that stops you executing code that you've written to. So memory can be read-write or execute. Well, it's always writable or executable, and that's done on a per-page basis. Certainly on many operating systems. So you would have to. When I did it years ago, you didn't need to worry about that. You could write and execute, and memory was memory. Maybe may still be the same on some platforms, but I believe now that you tend to be either writable or executable. You can change it using operating system calls, but it's a bit more involved. You can't. On some platforms, you can't just malloc some memory, write to it, and then take that, cast it to a function pointer, and call it. Which, yeah, where am I going with this? Is tangential, isn't it? Bytecode compiler. I just want to write one. It's meant to be fun. It will probably last longer. So if we do keep developing this little language on and onwards, then having a bytecode interpreter will be much better than having an AST interpretation method, because I'd always be thinking we've got to rewrite it. It would also, yeah, I mean, when you start getting into structures and stuff, they start to blur anyway, because in my mind they start to blur. I can't really vocalise it. Nice tea. I don't actually know what I grabbed out of it. Some sort of herbal lemon ginger thing. I should pay more attention. I was talking science. Right. Let's write a compiler. So, bytecode interpreter is a virtual machine. We get to specify the assembly language, the bytes, what they mean, the instructions of the virtual machine. So it could be push, it can be pop, it can be all these things. We also get to specify, what numbers you work with and all this sort of thing. So what we have to do is we have to have a structure called a program that will contain some stuff. then program will be returned by compile to write. That's going to take an AST pointer. Now all the types are already loaded on that. Let's leave it like that. Right, that's going to be our interface. There's going to be a lot of magic in there. We're going to do some stuff. Then, once we've got our program, we are going to have a function we're going to have a struct VM I always like the lowercase everything style of programming. Maybe I should move to it. Underscore T's. It's going to be private, but what we're going to have is avoid execute. Be clear. We're going to be typing that a lot. And we're going to do VM for now. Finally, execute. This is going to be here. You know what? We want to get access to the VM because no, I didn't do that in that. Just formatting the code in there. When we take the VM, so it cannot be a constant reference, we send the VM into execute rather than creating it inside execute because we may want to look at it on the way out. And that is the top level structure we compile to make a program. And then we run the program using the execute method. It's cool. That should build, yes. Okay. Right. One thing I want to avoid is doing too much about packing each instruction. Keeping these names deliberately short, at least for now. Instruction, that's going to have a that may be all we have. In which case we'll get rid of it. That is cool. We are there. construct class that. So no, there'll be more information. Again, I don't want to get into making it most optimal. As you might have seen, everything we've been doing is not optimal, not near optimal, in fact incredibly non-optimal, and I wouldn't get most of this through a code review at work, and justifiably so. This is very much Export stroke experiment program, which is the type I like to do at home. We plan is to harden it off once we get stuff working. I cannot remember where we put. Is it here? No, it's not. It must be there, the modifier at the end. I do it quite a lot. Why do I forget that? So there's always going to be some limits. Push. Pop. Those are for taking things on and off the hardware stack. So we're going to do a stack-based machine. We're not going to do any registers, anything like that. This is just going to be what we call some argument. We push them all onto the stack, and then the thing can read them. Oh, well, there's going to be a few registers or equivalent registers. We need a stack pointer and those sorts of things. And, so we are going to mimic a machine, but we're not going to mimic it too closely. But we want is a int. Got 8 bits there. And I want to do no, process off. I was not going to worry about types, so we're going to just do uint 32t value. This could be is it a text section of a executable text? Text is code, what do we call it? Data section? I'm going to have to look it up. I can't remember off the top of my head. Sorry, it's boring because I know it's off screen. Is the data section. What was I wondering? The BSS section is used for declaring variables. Section. Yes, it's the data section. The BSS section is for things that have to be initialized when you're going to have constants. So, data section or other things. So, read data jump. Okay. This is now 48 bytes. It's going to be on that because it's going to be padding, so I think it's going to be 64. Why don't you improve that? padding. Ideally I want it to be 8 bytes. So the instruction kind can be 32 bits. I don't feel the need for more than 32 bits for the value index, or even a value which we could cast out. It's oh God, it's getting late. So we might make use of these at some point. Okay, that's instructions. A program is just going to be a stored vector of instructions code and stored vector of I want to use standard byte, but I'm just going to use a char for now. Data. I will push everything into chars. Using char. Right. But so a program has the code and the data section. So this is the equivalent of an executable, which has many more sections. Like the code, data sections. Like just looked at the BSS section. It has the an executable that has all sorts of sections for handling exceptions and all other stuff. Flips top of my head because I'm no expert in this area. But that's the two things you need to actually. We've got code and data, and we may have some initialization stuff at some point. Entry point, which will almost definitely be 0, but we may as well have it formally there. That can be as big as we want. It's going to be awesome. Okay. VM has a stack. It has a stack, and it's going to have some registers. We're going to always know where it is. Oh, let's keep it playing out in what we want. We're going to have a stack and we have an instruction pointer. So instruction pointer is going to point at the next instruction. Here we're just going to have a loop that just keeps taking the next instruction, doing whatever it says, and going. So most of the logic is in most of the logic will be in the compiler. The bytecode should be relatively simple, maybe. That is a very brief overview of what we've got going on and what we're going to spend the next few weeks trying to figure out. I'm going to call it a night because it's got to 10:46. And while we haven't been coding all the time, we've actually only written one function and moved some files around. We've got and obviously bash this out. We've got a skeleton of what we need to fill in. I think my approach is going to be go down here and write a function. So we've got to do what's a minimum bit of code we can write. So if we point you out for a minute, we do auto code equals that's like the minimum function we can do. So we'll make main as the main language is the entry point, and we just want to go in there and main should return an I32, shouldn't it? And return an I32. So you see we're instantly doing something here. We want to make that a so we want to, so the minimum is we've got to be able to support a function call, so we've got to be able to call into main, which currently takes no arguments, so that'd be pretty simple. We just jump to the destination that is main. Then we shall evaluate what's inside that. So we have to, in the first case, we have to be able to call into main and evaluate the number 100. We have to write the number 100 to the static section, the data section. We could encode the number 100 as a value. So we could, I'm tempted, not to, just because, why not? I've got a feeling the stack's going to become a class of its own because we need to push aligned on. So if you push state, it won't matter now actually. So if you put state a char on, it will increase it by 1, which will make it the address odd. It would be a 0, it would be a 1. Well, an int 32 really wants to start at a 4 byte boundary. Otherwise there's 2 reads, potentially 2 reads as it goes and gets it. And some platforms it really doesn't like it. Again, don't take my word of this. It's been a while, let's say. But as we're always going to be writing, the smallest thing we're going to write at the moment is a 4 bytes. We don't need to worry about padding, so it should be good. Double's going to be 4 byte aligned as well. It's complicated. So eventually we may end up making this a class or a structure with some additional functions, but for now it should work like that. It may be we'll see how we go. Overthinking. So next time we code, we shall start to work on this. So we're going to work out how to compile it. We're going to work out many other things. kind of feels like the right decision, because deep down I would like to get to a point where we do generate some really bad assembly code to be assembled. Obviously you could just try and hook into an LVM, and that seems to be what most of them do, but I think it'd be fun for a little project to take the interpreter and have it compile with some shockingly bad assembly code written by me. So that'd be a nice step forward. So a lot of the problems we solve, for instance, the jumps for functions and things like that can all be, usually doing assembly, it doesn't matter, does it? But they're similar problems to what an assembler has to do, so it should be fun. And I'm meandering, and I'm going to stop and say, yeah, we'll probably change these, maybe, who knows, we'll see what falls out. So maybe tomorrow if I do stream, but otherwise Monday or Tuesday or Wednesday or Thursday, when I next get another stream, we shall carry on here. And that's about all. Okay then, have a good night. It's now 10 to 11 UK time, so I shall see you next time.